Hi everyone, I want to make a short video to help you get started with Unit 3. Unit 3 introduces the idea of functions and graphs, and we'll begin by looking at Section 1, which is the Introduction to Functions. This is on the first page of your Unit 3 notes template. A function is a relationship between two variables wherein the input variables don't repeat. The input variable corresponds to exactly one element of the output or the second variable. So in the two examples on the notes, part A, the pairing of a person with their birthday is a function because each person can only have one birthday. I'm going to draw a diagram, what we call a mapping diagram, to represent this relationship. And here's what it would look like. We'll have the person, and then we'll have the person's birthday. So, Layla might be born May 30th, 2018, and Layla would have one birthday. Jenna might have been born May 31st, 2017. Jenna would have one birthday. Carla may also have been born on May 30th, 2018. But look what happens here. In this example, the person is the input, the birth date is the output, and each input maps to an output, but none of the inputs repeat. So this is an example of a function. It doesn't matter that the output values repeat. In part B, the example that's listed in our notes says a person mapping to their telephone number is not a function. And let's see what that could look like. In this case, the input is the person, and the output is the phone number. And let's list our input people this time. Devontae, Caleb, Joshua, and Brandon. Okay, and again, you guys, we're going to draw a mapping diagram like we did in the previous example. Let's say the numbers are 615, 2344, 289, 3699, 910, 8294, 259, 3117. And let's say that Devontae has two numbers. He has a home number and a cell number. Let's say that Joshua has this phone number. Caleb has this phone number, and Brandon says his is unpublished. Well, look what happens here. The person is the input, the phone number is the output, and in this case, we see that Devontae has two numbers. So Devante, the input, would repeat because the Devante is associated with the 615 number and also the 289 number. So this would not be a function. Let's do another example. This time, let's use what we typically see in math, a relation, a set of ordered pairs. And before we do that, let's list some terms. The input value is also typically our x, and the output is the y. Also, the input values could be called the independent variables, whereas the output is the dependent variable. And then the set of all the input values is called the domain, and the set of all the output values is called the range. Excuse me. So these are just some key terms that we'll use in this section, in this unit. All right, so let's look at another example. We'll call this part C and continue deciding whether or not the relationship represents a function or not. So let's look at this diagram. Our input values are 4, 6, and 8, and the output values are -3, 2, and 0. And we will say that 4 maps to -3, and 4 maps to 2. And let's say that 8 maps to 0. Is this relationship a function? And the answer is no, it's not a function. Why not? It's not a function because this 4 maps to -3 and to 2. So the 4 is repeating, which means it's not a function. What would this look like written in ordered pair form if I didn't want to write the relationship using a mapping diagram? It could have been written in ordered pair form. And you're used to seeing ordered pairs when we were talking about graphing on the Cartesian plane. So the ordered pair would have been 4, -3. The other ordered pair would have been 4, 2. And then we had 8 mapping to 0. Again, this was not a function because the 4 is repeated. Let's move on quickly to the next topic that is on the agenda for our discussion. And that just reviews what I just described to you with regards to the independent and dependent variable. But I also want to talk about function notation. Function notation is a concept that was discussed in the DMA classes, but let's just review it to make sure everyone is on the same page. Typically, we're used to seeing an x-y relationship in an ordered pair. Well, function notation replaces y with f of x. And this is read f of x, not f times x. This is f of x. And all this means is we have a function named f. The function's name is f, that is defined or written in terms of the variable x. For example, we could have f of x equals 2x minus 3. This is function notation. It's the function f. The independent variable is x. That's the input. We also, again, call it the independent variable. And the output is f of x, which we are used to seeing written as y. Okay? We can evaluate functions, we can graph them. We know from our DMA modules that this is a linear function. If we were to graph this function, it would have a slope of 2, a y-intercept of -3. Let's go back to our notes and see what is the next topic. It's evaluating functions. So I'm going to rewrite this on the whiteboard that we just had. F of x equals 2x squared minus 3x, and we want to evaluate it for these given values. Okay? I'm going to toggle back and forth between these screens and try to do it before the time runs out so that I can make a series of videos. All right? So the function that we're evaluating, f of x equals 2x squared minus 3x. And we first want to find f of 0. What does this mean? This means substitute in a 0 in place of the x's that are in the function. So then we would have 2 instead of x squared. Now we have 0 squared minus 3 times 0. F of 0 would then equal, if we simplified, 0 squared is 0 times 2 is 0, minus 3 times 0 is also 0, so f of 0 equals 0. Similarly, we could find f of let's find f of 2. We would replace each one of the x's with a 2. And then we have to remember our order of operations. We would square 2 first. 2 squared is 4. And then multiply by this 2. So this would give us a product of 8. 3 times 2 is 6, so 8 minus 6 gives us 2. F of 2 equals 2. Let's do one more. I will clear the board this time. Our function was f of x equals, was it 2x squared minus 3x? And let's find f of -1. We are going to replace each one of the x's with a -1. So we have 2 times -1 squared minus 3 times -1. So f of -1 equals, a -1 squared is -1 times -1, which is a +1, and then times 2. So our 2 times 1 is 2, and then a -3 times a -1 is a +3. So f of -1 equals 5.